Hello everyone and welcome to Mathematics. So today's video will focus on everything you need to know on area under the curve. Using integration, how do we find area under the curve? So we have two steps, and the first step is to choose the axis that we want, right? So there are two axes, one is the x-axis and one is the y-axis, right? And here are the formulas. So to find the area, what we need to do is to integrate y in terms of x from a to b, right? So if x-axis means we need to integrate in terms of x, which means the things inside this integral later must be x only, right? So x-axis, make sure that the unknown is on the outside. For y-axis, it's the other way around. If y-axis, y must be outside, x must be inside. So now, let's look at examples of x-axis. Okay, so here we have two diagrams. So the first one here, we have this curve, and then the area under the curve would be here lah, right? Okay, so why x-axis? Okay, let's imagine the x-axis is not here. So our area under the curve, right, we can go beyond, right? But because of this x-axis, it, I would say, controls or is bounded by this x-axis. So our area can only go this far. Okay, which is why we need to use the x-axis, because this area is bounded by the x-axis, controlled by the x-axis. Okay, same goes to the second diagram as well. Okay, this one technically is area above the curve lah. Okay, because our area is something like this. Okay, but again, without the x-axis, we can go beyond, right? Something like this. But then, because of the x-axis here, the area only stops here, right? So this is why we need to use the x-axis. Oh, and also forgot to explain A and B. So A is a starting point, okay, and B is the ending point of the area. Okay. So what is the difference between these two? Why the area here is green and why here the area is pink? Okay, reason is because when we go into the walkthrough videos, right, you realize that for areas above the x-axis, it is actually positive. But if it is below the x-axis, it's actually negative. Okay, so now you'll be wondering, areas cannot be negative, so how do I solve my question? Okay, so if you have this kind of area, what we can do, very simple, is just to apply the modulus to our formula to change the answer from negative to positive. Okay, using modulus. So a lot of students will make this mistake. So we have this example, right? We want to find the area for these two parts. Okay, so a lot of students, they will do it this way. Straight integrate from 0 to 2. Okay, we ignore the modulus, just the things inside here, from 0 to 2. One go, find all the areas. But technically, right, because of this positive and negative thing, right, we know that this one is negative and this one is positive. And let's say this area is 3, this area is 2, but we know this part is a negative. So when we do this way, we are actually adding one positive and one negative value, which means we are minusing the areas. Okay, so what we can do is, instead of going from 0 to 2 straight away, what we can do is go from 0 to 1 first. Okay, and then we put the dx here. Then we go from 1 to 2. Okay, and since we know this one is negative, so what we need to do is to add the modulus lah. So instead of 3 and negative 2, now we have 3 and 2. And then because of this plus here, we are adding them together. So this is the way to find the correct area or shaded region. Okay, split them instead of combine those areas together. Right, so same goes to y-axis as well. Okay, but this one is bounded. Sorry, the areas are bounded by the y-axis lah. So you can see it from here. Okay, so this one, if without the y-axis, I can go beyond, but because of the y-axis, it stops here. Same goes to this area as well lah. Right? So for areas which is on the right side of y-axis, the area is positive. If it's on the left side, means it is a negative. Okay? So this is step 1. What is step 2? Okay, step 2 is to identify the shapes, but later I'll let you know why we need to identify. Okay, but first I'll let you know what are the shapes lah. Okay, so here we have 3, which is triangle, rectangle, and trapezium. These 3 shapes will be very helpful to find areas that the question requires. Okay, so let's go to some of the examples here. Okay, so we have a curve and we have a straight line here, and this is the area we need to find. So let's go to the first step. Which axis we should choose, X or Y? Right, so personally I'll give you all a tip lah. If you all see curves like this, right, smiley face or sad face, usually I would prefer you all to use X-axis. Okay, much more straightforward. Okay, so let me find the starting point and the ending point of this area, right? And let's go to a second step, which is to identify the shapes. Okay, reason we to identify the shapes is because there's one technique to find area or shaded region, which is big shape minus the small shape. So big shape means areas that includes the shaded region. Okay, so the big shape here I would say is this. Okay, you can see that this part is actually a trapezium and it includes the area of shaded region. Okay, so now I have a big shape. I need to minus out the unimportant parts, which is here, right? The below part. The below part is actually area under the curve, right? Area under the curve. Okay, so I already found my 2 shapes. The big shape, which is the trapezium, minus the small shape, which is area under the curve. Okay, so to find the area or shaded region, I just need to do this. Big shape minus small shape. This one I can use the area of trapezium formula, and this one I can use here, the formula from here, to find the area. Then I minus them together, then I can get my answer. Right? Second example here, we also have a curve and also have a straight line. So this curve is a smiley face, so we can use the x-axis lah. Okay, and also there's another tip is you can see that the area of the shaded region required, this area is also bounded by the x-axis. Okay, so it's much more clearer that we need to use the x-axis method. And let me draw out the end point of this area, okay, which is here. So step 2, identify the shapes. So this one, there's another technique to find area of shaded region. So you can see here, this part is actually bounded by the curve. Oh, sorry, it's area under the curve. But for this part, it's actually the area under this straight line. The area is bounded by 2 different lines. Okay, so what we can do is to separate them. Okay, separate them so you can see there are 2 different shapes. So here on the right side is actually area under the curve lah. Okay, and for this part is actually a triangle. So another technique here is to add up the shapes. So the next example is here we have a curve and a straight line, but this curve is not a smiley face or a sad face. Okay, so this is a hint that we should use the y-axis method. Okay, so this is the area of shaded region. We are using the y-axis. So to find our starting point, this is our starting point. The end point would be here for our area. And step 2, to identify the shapes. So here we can use the big shape minus small shape technique. So the big shape here, I would say, is the area under the curve lah. Okay, somewhere in this part. And then the unimportant parts is this space here, which is actually the triangle lah. So we can minus these 2 areas together. This area I can calculate through this formula. This one is just using the area of triangle formula, and minus them together to find my area. Okay, so this one is the technique, which is big shape minus small shape. Okay, the next example here, we also have a curve, not a smiley face, not a sad face, so another indicator, we should use the y-axis lah. Okay, so this is the area of the shaded region, and you see that this area is also bounded by the y-axis, so confirms that we need to use the y-axis lah. Okay, and then yeah, so step 2, identify the shapes. So what we can do is, you can see if we use the y-axis, this part is bounded by the curve line, but this part is bounded by the straight line. Okay, so again, we can split this area into 2. Right, split this area into 2. So for this part bounded by the curve, we can use the integration formula lah. Area under the curve. Okay, and this one is actually a triangle. So what we can do is to add these two areas together to find the area of shaded region. Okay, so this is everything you need to know on how to find area under the curve using integration. Right? So I'll put the links in the video description for more examples about this. Okay, so feel free to check it out. And if you have any questions regarding this video, feel free to write your questions in the comment section below. Okay, so thank you so much for watching. Take care, and I'll see you in those walkthrough videos. Bye bye.